right, ladies and gentlemen, so today we're getting into something called percent error problems, and these are actually used in manufacturing, in any type of engineering, in science classes, in medical studies, in statistics. So you're like, well, why the heck are we learning about it now? Well, we might as well start now and learn some of the basics, because obviously it can get much more difficult as you get into those topics. But the absolute error, so we're going to be talking about two things. Absolute error is defined as, and remember that these are absolute value symbols. Right, that's what those things are there. So it's basically saying that if I take and subtract the exact value, or what it's supposed to be, the true value, and what I got in terms of a calculation or a measurement, or if I was doing an experiment, if I subtract those, that's called the absolute error. The percent error is taking and where I do approximate minus exact, same on the top, divided by the exact times 100. In other words, now I'm comparing it to the exact value, or what it should be. And a good measurement, right here, the smaller the percent, the better a measurement is. All right, so let's see what we're talking about here. A realtor expected 18 people to show up for an open house, but 25 attended. They want us to calculate the percent error. So this is the one formula that clearly is different than our other percent problems. So what we're doing is we're going to subtract. So this is the expected, this is the actual. So I prefer to do, so we're going to do 25 minus 18 divided by, and the exact value in this case is how many they expected to show up, times 100. So if I do that, right, so 25 minus 18 is 7, and then 7 divided by 18 times 100. So that gives me a percent error of 38.8%. So in other words, her estimate was off by 38.8%. Or what actually happened, I should say. In science class, Mrs. Moore's students were directed to weigh a 300-gram mass on a balance. Tina weighed the object and reported 328. So this is the actual, and then this is the measured. So in our formula, let's go back up here and let's add these in. So your approximate is really also your measured, and the exact is your actual. All right, so let's go down here. So we want to, it doesn't say, but it says we're trying to figure out what our value is here. So we're going to do 328 minus 300. Right, so you're always subtracting them. You're comparing it to its actual times 100. So this is 8 over 300 times 100. So 8 divided by 300 gives me, times 100 is going to give me 2.7 if I round to the nearest 10. 2.7%. All right. Derek's coach recorded that he had bowled a 250 game in a bowling tournament. The maximum score he could have rolled is a 300. However, the official scoreboard showed that Derek actually bowled a 225. So this 300 has nothing to do with it. All right, so here's our actual. Here is our measured. And we want to know, well, what was the percent error? So we're going to do 250 minus 225 divided by 225 times 100. Right, because it's always, down here is always the actual value. So 225 minus, or sorry, 250 minus 225 divided by 225 is going to give me 11.1%. All right, over here. So a classroom is in the shape of a rectangle, has been cut diagonally, measuring at 15 inches. A sample list of 3 students' measurements were recorded in the list below. Determine the error for each student's measurement to the actual measurement. So our actual is supposed to be 15 inches. All right, so we'll do Taylor's. So we have 15 and 2/8 minus 15. I always subtract so that I have a positive value. Divided by 15 times 100. So that is 2/8 divided by 15, which is going to give me 1 point, determine the error, it doesn't say, I'm going to round to the nearest tenth, so 1.7%. For Connor, we have 15 4/8 minus 15 divided by 15 times 100, sorry, which is going to give me 3.3%. And then for Jordan, we have 15 6/8 minus 15 divided by 15 times 100. So we have divided by 15 times 100, and we're getting 5% for that one. All right, so doing all three of them. So the attendance at a musical event was counted several times. All counts were between 573 and 589. If the actual attendance number is between and included 573 and 589, what is the most the percent error could be? Explain your answer. So the most it could be is when I subtract those, 589 minus 573. Now, what I have to worry about, because it doesn't tell me what the actual is. So if I want the biggest, that means I need the smallest number here. So I would divide by 573 times 100. So 589 minus 573 divided by 570. I don't know why I wrote 5 there. Sorry about that. That's supposed to be 573 times 100. So our biggest percent error is 2.79%. All right. Let's see. Do we have anything on the next page? Nope, that's our practice. So again, knowing that exact and actual mean the same thing here, and then you're measured, and you're always doing your subtracting to find, to make it a positive number or put it in absolute value symbols. Any questions? As always, bring it to class and have a good night.